Hello there. Today I'm going to attempt to walk through this A-level question, which was from an international Edexcel A-level paper. It was the P3 paper in January 2021. And to make it a bit easier for me, I'm just going to break it down into each section. And to get the appropriate pen thickness before I get started, I really like to write in the correct pen. Okay, I've got x is equal to 3x squared 2y. I've got x is bigger than 3 and y is between 0 and pi over 4, so I know that this is in radians. I've got to find dx dy, so I've got to differentiate x with respect to y. And I don't really like the way it's written out, so what I'm going to do is I'm just going to rewrite it. X is equal to 3 lots of sec 2y squared. That's what sec squared 2y actually means. When it's written like that, it's much easier to see that you need to use the chain rule here. So I'm going to let x equals 3u squared, where u is equal to sec 2y. Now, if I do dx du, I know that I get 6u. And if I do du dy, now I know that the differential of sec is sec x tan x, or sec y tan y, or in this case sec 2y tan 2y. But here I've got to be very careful because I know that I've got to multiply by the differential of that little angle there. So it's going to be 2 lots of sec 2y tan 2y. Now, if I use the chain rule and I want to find dx dy, I can use the chain rule by multiplying dx du by du dy. I like to formalise it like that. And that means I've got 6u being multiplied by 2 sec 2y tan 2y. Because I want to substitute the u back in, that's going to be 6 lots of sec 2y being multiplied by 2 sec 2y tan 2y. So therefore dx dy is going to be 12. Then I've got sec squared 2y tan 2y. It said to find dx dy in terms of y, and I do believe I have done it. So that is going to be my answer for part A, and that is actually correct. Part B says hence. I've got to be really careful with the word hence, because when I can see the word hence, I've got to use what I did previously in order to answer this question. So if I completely use a different method, I'm not going to get any marks for that. It does say hence, I have to use what I've just shown. Okay, hence show that dy dx is this fraction. Okay, all right then. So I do know that dy dx is the reciprocal of dx dy. Now, I think before I get started in doing any reciprocals, I think what I'm probably going to do is make some substitutions or something like that. I also notice that this is in terms of x. And here my answer was in terms of y, so I probably need to do something about that as well. Okay, so I think what the first thing I'm going to do is I'm going to try and rewrite. So this is my first little aim. I'm going to write dx dy first of all in terms of x. I think that's going to really help me. Sometimes it's really hard to know where to start, but I think that's what I'm going to do. Now, I'm going to remember that x, at the beginning of the question, was written as 3 sec squared 2y. So if I look in my expression for dx dy, I need 12 sec squared 2y. And I know that's 4 times as big, so I think that's going to be equal to 4x. That's nice. So I've got the first part of that as 4x there. But tan 2y I'm going to need to express as well. So let's have a little think about this. So I know that x is equal to 3 sec squared 2y. And I also know that sine squared a plus cos squared a is equal to 1. And that's an identity that I know and love. I use it a lot, actually. I'm just going to highlight that in a different colour. Now, I do remember that there's a relationship between sec and tan, or I should say between sec squared and tan squared, but I can never remember which way round it is. So the way I get round that is I kind of think to myself, how would I get a sec squared in there? So sec squared is 1 over cos squared. So if I divide every single term of my identity by cos squared, that enables me to see, therefore, that tan squared, my angle, plus 1 is equal to sec squared, my angle. Okay, so if I know that, then I know that sec squared, oh, I've just realised x was equal to 3 sec squared 2y. I got that wrong. Okay, so if I have sec squared 2y, I know that's going to be equal to tan squared 2y plus 1. So if I go back over here, I'm going to rewrite x as 3 lots of tan squared 2y plus 1. Now, what I'd really like to do is I'd really like to make tan 2y the subject, because up here I've got to express that in terms of x. So if I can make tan 2y the subject, that'll be a really good thing. Okay, so I'm going to try and do that. Right, so therefore I know that x is equal to 3 tan squared 2y plus 3. I therefore know that x subtract 3 is equal to 3 tan squared 2y, and therefore x minus 3 over 3 is equal to tan squared 2y, and therefore if I square root both sides, x minus 3 over 3 is going to be equal to tan 2y. Okay, so I'm just going to rewrite dx dy now. So that tells me, therefore, where am I going to write this? Maybe up here. Okay, so I've got dx dy is now 4x, because 12 sec squared y. Let me write this again. 12 sec squared 2y and tan 2y. Okay, so I know that 12 sec squared 2y is 4x, so that is equal to 4x. And I also know that tan 2y is equal to the square root of x minus 3 over 3. So I think I'm going to make that substitution there, and I'm going to show you where that substitution came from, just in case you're confused about that. So 4x is being multiplied by the square root of x minus 3 over 3 there. Now I can kind of see that that's looking a little bit more like part B. It wants dy dx as that formula fraction. So I think before I do a reciprocal, I'm going to be really clear that that means 4x multiplied by root x minus 3 all over the square root of 3, and that is dx dy. Finally, to find the reciprocal, dy dx, which is what I've been asked to show, that is going to be the reciprocal. So I've got root 3 all over 4x root x minus 3. It says where p is irrational. Ah, yes, I can see p on top on the numerator. P is root 3, and q is an integer. So I think q is the number in front of the x, the coefficient there, and q is equal to 4. Just double checking on my solutions that I got earlier, and they are correct. Okay, so I'm just going to pop those in a little box to highlight those. Okay, part C. All right, so part C says, find the equation of the normal to the curve at the point where y is equal to pi over 12, giving your answer in the form y equals mx plus c, giving m and c as exact irrational numbers. Okay, right, so I'm told y is equal to pi over 12, and I think I'd really want to know what x is equal to. So if I think back to the beginning of the question, I've got x is equal to 3 sec squared 2y. So I'm going to write that x is equal to 3 sec squared 2y. Okay. I'm just going to remember that x is equal to 3 and then sec 2y being squared. And I think that when you're making any kind of substitution, it's really, really helpful, because your calculator doesn't have a sec button on it. I think it's really, really helpful to write it out as, you know, one of the three basic trig functions. So sec is 1 over cos, so 3 lots of 1 over cos 2y, which is being squared. So when y is pi over 12, I think I'm going to make that substitution. X is equal to 3 lots of 1 over the cos of 2 pi over 12, just multiplying that angle by 2, squared. I'm going to go grab my calculator now and type that all in, making sure my calculator is in radians. That's the most important thing. I need that in radians there. I'm going to type that in. So I've got 3 lots of, and then I've got that big fraction, which is 1 over the cosine of 2 pi over 12. And I'm just going to type it in exactly as it is there, all squared, and I end up getting 4. So that's nice, lovely. So I've got x equals 4 and y equals pi over 12. Nice, I'm definitely going to need those. Thinking about the equation of the normal, so I've got the gradient of the tangent of the curve, which is dy dx. The gradient of the tangent to the curve, which is equal to dy dx, which is the expression I got above, which is, let me just make that a little bit smaller. It's all very confusing. Root 3 is a very big question, actually. I think this was the last question on this paper. Okay, now we've got x is equal to 4. So when x is equal to 4, dy dx is going to equal, we've got root 3, 4 times 4 is 16, and 4 subtract 3 is 1, so root 1, which is just 1. So I've got root 3 over 16. That's the gradient of the tangent. But this question wants you to find the equation of the normal. So remembering that the gradient of the normal is always the negative reciprocal. So therefore the gradient of the normal is the negative of 16 over root 3. I like to rationalise the denominator when I can, so I'm going to do that, which is negative 16 root 3 over 3, which can't be simplified anymore. Now, it wants the answer in the form y equals mx plus c, so we might as well write y equals mx plus c, and then substitute those values. You know, I've got y, which is equal to pi over 12. Okay, so let's find c, y equals pi over 12. So I'm just going to write down that I'm finding c. I suppose what I probably would write down first is y is equal to m, which is negative 16 root 3 over 3, x plus c, and then we find c. I just like to write that step in. It's much clearer what we're doing, I think. So y is pi over 12, remembering that x is 4, so I've got negative 16 root 3 over 3 multiplied by 4, and then plus c. So I know that pi over 12, and if I multiply 16 root 3 by 4, that's going to be negative 64 root 3 over 3 plus c. And then I can see that if I add 64 root 3 over 3 to both sides, I can see that c is going to be equal to pi over 12 plus 64 root 3 over 3. Okay, so therefore, lastly, the equation of my normal is, so I've got y equals, my gradient is negative 16 root 3 over 3 x plus c, which is pi over 12 plus 64. Whoops, that's definitely not 4. 64 root 3 over 3. And that is the answer. If you wanted to combine the two fractions for c and make it into one fraction, you absolutely can do that if you really want to. If it kind of aligns more with your values, you can. So you do like 4 lots of 64 multiplied by root 3 over 12. You can do that if you want to. 4 lots of 64, so for double that is 128, double that is 256, which I can do. which is pi plus 256 root 3 over 12. So an equivalent answer, if you really wanted to do that, which often I do actually. I wouldn't necessarily advise it in an exam, because if you go wrong by combining those two fractions, then you're going to lose your answer mark. But yes, you can have it like that as well. Anyway, thank you for listening. That took me 15 minutes to answer that question. It was a long question. It was the last question on the paper. Thank you very much for watching.